Hello everyone, thank you for watching this video. Now in today's part of the lesson, we are going to cover chapter 1 part 3, square roots and cube roots. Now in our previous lesson, we already completed exercise number 10, explain why a number is a perfect square or a number is a perfect cube. So moving on, we are going to explain our next few examples of the different types of questions available. First one, example 1a over here. Given that 45000k is a perfect square. Now, what is the meaning of a perfect square? So firstly, if I have a number that is a perfect square, it means all the powers of its factors, okay, are in multiples of 2. So they must come in 2, 4, 6, 8, 10, okay, something like that. Okay, and they say write down the smallest possible value of k. So what I want to do is I'm going to multiply by a number k, right, to this number to make it a perfect square. So when I multiply certain numbers, right, and that means what happens to my power? When I multiply something, my powers increase. Okay, this is one key important factor that you need to understand. So when you multiply, when this question here is multiplying by k, you multiply by k, not dividing. When you multiply by something, the powers of all the factors will increase. So first, how to handle this kind of question? First, let's express the number 45,000 as a product of its prime factors. So after calculation, so I have 45,000, right, as the product of its prime factors to be 2 cubed, 3 square, and 5 to the power 4. Next, let's consider the letter k. What is this number k that I need to multiply to make it become a perfect square? So firstly, which of the factors here are not a perfect square? That means which of the factors here does not have power that are multiple of 2? Well, you can see very obviously, this is 2 to the power of 3. The power here is 3. So in this case, this is not a perfect square. So when I have multiplying by k, when I multiply by something, I want my powers to increase. Do I want to make 2 cubed, okay, to increase my power to 2 to the power 4? Or do I want to decrease, okay, my power to 2 square? So in this case, my power can only be increased. So I need to make it become 2 to the power 4. Now, what do I need to multiply here to make it become 2 to the power 4? There's already 3 of the factor 2. I need one more factor. So it will be factor 2 to the power of 1. Okay, then let's check the others. So the first one settled already. Let's check that. Is this already a perfect square? Well, this is 3 square. Of course, it's a perfect square. The power is a multiple of 2. Then this is 5 to the power 4. The power is a multiple of 2 as well. So 5 to the power 4. So this is already a perfect square. So what is the number, the smallest possible value of k that I need to multiply? So k is just the answer. K equals to 2. That's the answer. Okay? Right? Now, similarly in this kind of question, let's consider if, let's say, I want to make 45,000 times x a perfect cube. So if I want it to be a perfect cube, what does that mean? That means the powers must be multiples of 3, correct? So some of you are already thinking of powers multiple of 3, right? So when I have a perfect cube, the powers must be multiple of 3. So again, I'm multiplying by something, 45,000 multiplied by x. So when I multiply something, the powers increase. Okay? So I'm going to find the smallest possible value of x. What is the thing that I need to multiply to make it a perfect cube, such that all the powers are multiple of 3? Let's find what is this x. Firstly, let's check. 2 to the power cube. Is this already a perfect cube? Well, yes, the power is a multiple of 3, so no problem. Next one, I have 3 square. 3 square, this is not, the power is not a multiple of 3. So what am I going to do? Am I going to make 3 square increase the power to make it become 3 cubed? Hey, remember, multiples of 3, 3, 6, 9. Or I'm going to totally make 3 square disappear. No 3 square, no more 3. Okay, make it totally disappear, or should not put 3 to the power 0. Just make it no more 3 at all. So in this case, I need to increase my power, right? So I need to increase my power, so I have to choose 3 to the power 3. So let's check what is this number I need to multiply. I already have 3 square, already got 2 of them. How many factors are missing? So I need one more. 3 to the power of 1. Okay, next one, let's check. I have my next factor, so this one done, right? This one done. Next one, 5 to the power of 4. I need to have 5 to the power of 4. Remember, I need to increase my power. The multiples of 3, 5 to the power of 3. This is if I decrease the power. Or the next multiple will be 5 to the power of 6. Question, I'm multiplying. My powers need to increase. Do I choose 5 to the power of 6 or do I choose 5 to the power of 3? I want to make it become 5 to the power of 6 because I can only increase my power. My power increases, so I can only increase my power. So in this case, I must make 5 to the power of 4 become 5 to the power of 6. Then my next question comes, how many more factors must I multiply so that there is originally 4 of them and now it becomes 6 of them? So I'll take 5 to the power of 2. Have you gotten the correct answer? So I need to have 3 and 5 to the power of 2. But they want the smallest possible value x. They did not say leave it as a multiple of its prime factors. So in this case, I have to write out the answer. X equals to 3 times 5 squared, 3 times 25, which gives me the number 75. Have you gotten the concept? Let me just quickly re-explain this portion again. When you multiply certain things, the powers need to increase. So in this case, I'm increasing my power from 5 to the power 4 to become 5 to the power 6. I cannot decrease the power to become 5 to the power 3. Okay? So when I multiply, my powers increase. Then my question is, when will be the case when my powers decrease? Maybe you'll find out a bit later. Okay, so let's try a few more examples over here. Let's try example 2. Now let this a be this number and I want a times y to be a perfect square, meaning the power must be multiple of 2, right? And multiplication, multiply, the powers increase, right? And it's a perfect square, power must be multiple of 2. Let's check. Let's take a look at our factors here. This is 2 to the power of 5. Is this already a perfect square? So how I'm going to change to the power of 5? Am I going to increase the power to make it become to the power of 6, the next even number? Or am I going to decrease the power to make it become to the power of 4? Oh well, I need to increase my power. So from 2 to the power of 5, how to make it become to the power of 6? I need one more factor 2 to the power. Next, I have 3 to the power 11. Now, I need to increase my power. So in this case, I'm not going to consider a decrease. So I have to increase my power. So it needs to become 3 to the power of 12. So I need to have one more factor of 3 to the power 1 to make it become 3 to the power 12. Another one, 5. 5 is on its own. I need to make it become the nearest perfect square. Either have more 5 or less 5. So in this case, I make it increase to 5 to the power of 2. So I need one more power 5. 5 to the power 1, 5 to the power 1, so that becomes 5 to the power 2. So in the end, what is this value for my y? I need to multiply out the number. 2 times 3 times 5, that will give me the number 30. Have you gotten the answer? Let's try one more question. Question 2b. Now, if this is the case for B, and BM is a perfect cube. So they want a perfect cube, right? Perfect cube meaning power must be multiple of 3. 3, 6, 9, 12. So in this case, I'm multiplying. How do I know I'm multiplying? Because this one say B times N, right? So it's multiply. So in this case, my power will increase. Let's take a look. 2 to the power 4. What am I going to do? Am I going to make it become increase multiple of 3? Am I going to make it become to the power 3 or to the power 6? 3, 6, 9, 12. So in this case, I can only increase my power. So I have to choose 2 to the power of 6. From 4 to the power 4, how can I make it become to the power of 6? How many more factors do I need to multiply? So I need 2 to the power of 2 more. Do you get the answer? Next one, 3 to the power 11. What is 3 to the power 11? So the nearest power to increase my power. So the nearest multiple will be 3, 6, 9, 12. 3 to the power of 12. I'm not going to decrease my power to 3 to the power of 9. Yeah? So in this case, no. So I'm going to have to increase my power. So 3 to the power 11. How many more factors do I need to become 3 to the power 12? So I need one more factor, 3 to the power 1. Have you gotten the answer? Next one, factor 5. I need to make it become a perfect cube. So it must be 5 cube or totally no 5. Okay, at all. So in this case, they say power must increase. So we choose 5 to the power 3. This is 5 to the power 1, divisible number. From 1, how did he get to the power 5 to the power 3? So how many more factors do we need? 5 to the power 1 become 5 to the power 3. I need 2 more factors of 5. So it'll be times 5 to the power 2. Okay, but they want the smallest possible value. Never say leave it in index notation. So 2 square, 4 times 3 times 5 square, which is the number m equals to 300. Have you gotten the concept? Okay, if you have gotten the concept, we're going to move on to the next type of concept. Okay, let me do the questions at the bottom, example 11 on your own later. We shall try example 3a. Okay, now just now we had a couple of cases where it's multiplication. My power need to increase. So now my question is, if I were to do this, let's see with these factors, okay, this number, but now is c divided by p. So when we have division, when we have multiplication, the power increase. When we have division, what happens to our power? Our power will decrease, correct? Okay, and they want it to be a perfect square. That means all the powers are multiples of 2, right? 2, 4, 6, 8, something like that, or totally no 2 at all. Right, so let's take a look at the first one. What is it that I need to divide away? So in this case, I need to take c, divide away something. Right, first factor, this one over here is 2 cube. Let's consider 2 cube. Right, 2 cube. Am I going to increase my power to 2 to the power 4? I'm going to decrease my power to 2 to the power 2. Since this is division, the power will decrease. So I need to do division to make it become 2 to the power 2. So from 2 to the power 3, what do I need to divide with so that it becomes 2 to the power 2? Oh well, we need to divide by 2 to the power of one more factor 2, 1, so that I get only 2 squared. Okay, so when I divide, my power need to decrease. So I need to think 2 to the power 3, what other factors do I need to take away, to remove, okay, to divide away, so that my power can become 2 to the power 2. Okay, next one, 3 to the power 6. 3 to the power 6 is already a perfect square, so there's nothing I need to do to it. What about the number 5? Oops. Am I going to increase the power to make it 5 squared? Or in this case, I can't increase my power, right? They say division, power decreases. So my only other option is to make 5 totally disappear. So how to make 5 totally disappear? So I cannot increase the power to make it 5 squared. So I divide by its original value, 5 to the power of 1. So that after that, I cancel away. Is there any more 5? Cancel, and get the number 1. There will be no more factor 5. Okay, so in this case, I'm going to divide away the additional factor 5 as well. Okay, so this p is the number that I'm going to divide away. So therefore p is equals to number 10. Have you gotten the concept? Okay, let's take a look at one more example, a few more examples here. Next example, d is made out of these factors, and I want to divide d by letter f, division. So where it becomes a perfect cube. So where the powers are multiples of 3. So I'm going to divide it. So when I divide the powers, what happens to my powers? They will decrease. Okay, so let's take a look. The first one, 2 to the power of 3. Oh, this is already a perfect cube. I don't need to worry. Next one, 3 to the power of 5. So I have 3 to the power of 5. I need to make it become multiples with the power multiple of 3. So I'm going to make it become 3 to the power of 3. Or am I going to make it become 3 to the power of 6? The nearest multiple are 3, 6, 9, 12. So 3 and 6, right? So question, they say division, power decreases. So I need to decrease it, okay, to make it become 3 to the power 3. So this is 3 to the power 5. There are 5 of them on the numerator and 5 factors on the numerator. How many more factors do I need to divide away to give me 3 to the power 3? So from 5, how many factors do I need to take away to give me to have only 3 factors? So I need to divide by 3 to the power of 2. Have you gotten the answer? Next one, let's take a look. 5 square. Oh, 5 square is not a perfect cube. So I have 5 square. Am I going to increase the power to make it become 5 cube? Oh, lower than that, there should be no more 5. No more factor 5. So in this case, since power decreases, so I do not have a choice. I cannot increase my power. So I must make totally 5 square disappear. So 5 square, there are 2 of them, 2 factors on top. What do I need to divide so that it become no more 5? So I need a 5 square as well, right? So that I can cancel out this 2. There will be totally no more 5. So in this case, I will have another 5 square. They want the smallest possible value of f. Therefore, f equals to 9 times 25, 2 to 5. Have you gotten the concept?